Imagine standing on a busy street corner in the heart of a major city in the year 1850. If you look around, the world feels strikingly horizontal. The buildings are grand, constructed from heavy stone and brick, but they all seem to stop at nearly the same height. Most structures reach only 4 or 5 stories toward the sky. To go any higher is considered a feat of physical endurance rather than a triumph of architectural engineering. If you want to reach the top floor of any building, you have to use your own 2 legs to carry you there. Every step up a flight of stairs is a tangible reminder of the constant pull of gravity. For the people living and working in these cities, the upper floors are the least desirable places to be. They are hot in the summer, difficult to reach after a long day, and usually reserved for servants, storage, or those who cannot afford anything better. The wealthy and the powerful live as close to the ground as possible, because the stairs represent a barrier that no amount of money or influence can truly overcome. During this era, there was a hard limit on how a city could grow. As more people flooded into urban centers looking for work and opportunity, the only way to accommodate the rising population was to spread outward. This created a sprawling, disconnected landscape where the edges of the city pushed further and further into the countryside. We already possessed the technology to build taller walls, and the masonry techniques of the time were more than capable of supporting additional weight, but we lacked a way to make those upper levels useful to a human being. We had hoists and pulleys, of course. For centuries, miners and warehouse workers had utilized basic platforms to lift heavy loads of coal or crates of grain. However, these machines were notoriously dangerous and unreliable. They relied on a single rope or a simple chain to hold the weight. If that rope frayed over time or the gear slipped during a heavy lift, the platform would plummet to the ground. It was a risk people were willing to take for a sack of flour or a bundle of timber, but almost no one was willing to bet their life on a machine that could fail so catastrophically at any moment. This was the technological bottleneck that kept the skyline flat and predictable. The core of the problem was not the act of lifting itself, as we had mastered the mechanics of moving weight upward quite early in our industrial history. The problem was the falling. People needed a guarantee that if the mechanical system failed, they would not pay for that failure with their lives. Without that fundamental trust, the concept of a vertical city was a dream that stayed grounded in the dirt. Then came the year 1853, and a man named Elisha Otis. He did not actually invent the elevator in its entirety, as the concept of the lifting platform had existed for generations. Instead, he did something much more important for the future of humanity. He invented the reason to trust it. He looked at the problem of the elevator and saw that the world did not necessarily need a better motor or a faster pulley. It needed a better way to fail. The breakthrough happened in a very public and highly dramatic way at the World Fair in New York City. Otis stood on a platform that was hoisted high above a gasping crowd of onlookers. He had packed the platform with heavy crates to demonstrate that it could handle a significant load. As the audience watched from the ground below, he did something that seemed unthinkable at the time. He ordered an assistant to cut the only rope holding the platform in the air. In a terrifying instant, the rope snapped and went slack. The crowd likely expected to witness a horrific tragedy. But instead of a terminal crash, there was a sharp mechanical click that echoed through the hall. The platform jerked for a split second and then stopped almost immediately. It did not fall more than a few inches before coming to a complete rest. Otis looked down at the stunned onlookers and announced to them that everything was safe. What had changed in that moment was a simple but brilliant mechanical safety brake. Otis had designed a system where the tension of the lifting rope held back a set of heavy, powerful springs. As long as the rope was pulling the platform up, the springs remained compressed and inactive. However, if the rope went slack or snapped, those springs would immediately snap outward and drive metal teeth into notched guide rails that ran along the sides of the elevator shaft. The weight of the platform itself would then serve to lock it even more firmly into place. It was a fail-safe mechanism in the truest sense of the word.
It meant that the worst-case scenario for an elevator ride was no longer a disaster, but merely a minor inconvenience. This was the pivotal moment when the ceiling on human architecture was finally shattered, allowing our ambitions to point toward the clouds.
Once people realized they could ascend to great heights without the constant fear of falling, the economics of the city began to flip upside down. Before the introduction of the safety elevator, the ground floor was the most valuable real estate in any building because it was the easiest to access. After the safety elevator became a reality, the concept of the penthouse was born. Developers realized that if they could whisk people to the top of a tall building in comfort and safety, they could charge a premium for the view, the light, and the fresh air found away from the street level. The very top of a building went from being a dusty attic or a servant's quarters to being the ultimate status symbol of the elite. This shift sparked a massive and unprecedented wave of construction that redefined the urban experience. The adoption of this technology started slowly, primarily appearing in luxury hotels and high-end department stores. These were places where luxury and novelty went hand in hand, and a ride in an elevator was marketed as an experience in itself. These early lifts often featured plush seating, ornate wood paneling, and chandeliers, making the journey upward feel like a trip in a moving parlor. But as the technology proved its reliability over years of service, it moved rapidly into the world of commerce. Office buildings started reaching higher and higher, competing for prestige and space. By the late 1800s, the skyline of cities like New York and Chicago began to look like the jagged teeth of a saw. The skyscraper was no longer just a theoretical idea. It was a physical reality that was changing the way humans interacted with their environment. Scaling this technology required more than just the safety brake. It required an entirely new way of thinking about how buildings functioned as living organisms. Standardized systems for maintenance and operation had to be developed from scratch. A new class of mechanics had to be trained to understand the intricate workings of the cables and the safety catches. Building codes had to be completely rewritten to account for these deep vertical shafts running through the heart of every major structure. The elevator became the central nervous system of the modern building. If the elevator was down, the building was effectively paralyzed, and its upper floors became useless islands. This led to a massive secondary industry focused entirely on reliability and speed. We moved from the early steam-powered engines to hydraulic systems, and eventually to the powerful electric motors that dominate our world today. The ripple effects of this one safety lesson were profound and far-reaching. The primary winners were the city centers. Land that was once only big enough to support a small shop or a single-family home could now house thousands of workers or residents in a single vertical column. This extreme density drove a surge in innovation as people were packed closer together, sharing ideas, resources, and culture with more frequency than ever before. The losers were the old ways of life that relied on horizontal sprawl and slow movement. The very shape of our daily lives changed in response to this invention. We started living and working in the air, separated from the ground by hundreds of feet. The elevator allowed us to disconnect the value of land from its physical footprint on the earth. You could buy an acre of floor space while only occupying a few hundred square feet of dirt. As the 1900s progressed, the elevator became so integrated into our lives that we eventually stopped noticing it. It transitioned from a mechanical marvel into a quiet, invisible piece of infrastructure that we expect to work without question. But its impact only grew as cities became more crowded. Without this technology, the modern megacity would be a physical impossibility. Imagine trying to navigate a place like Tokyo or Dubai if every person had to climb 50 or 80 flights of stairs every morning to get to their desk. The entire concept of urban density and global commerce relies on the fact that we can move vertically as easily and as safely as we move horizontally. This story matters today because it teaches us a fundamental lesson about the nature of human progress. Often, the thing holding us back from the next great leap is not a lack of power or a lack of materials. It is a lack of safety and the trust that comes with it. We can build almost anything we can imagine, but we will not truly use it or integrate it into our lives until we trust that it will not kill us when it inevitably breaks. The skyscraper was not born from a new type of stone or a faster engine. It was born from a failure that taught a winning lesson. By designing a system that failed gracefully, Otis opened the door to a new dimension of human existence. Today, we take that safety entirely for granted. We step into a small metal box, press a numbered button, and trust that a complex series of cables, sensors, and brakes will keep us suspended hundreds of feet in the air. We check our phones or stare at the changing floor numbers, rarely thinking about the intense physics involved in our ascent. But every time we reach the top and the doors slide open, we are benefiting from that moment in 1853, when a man risked his life to prove that a broken rope did not have to mean a fatal fall. Our cities are towering monuments to that trust. As we look at the giant towers of steel and glass that define our modern world, it is easy to forget that they are held up by more than just their deep foundations. They are held up by the systems that allow us to inhabit them safely. But even with the perfect elevator, there was still another physical limit to how high we could go. You can have the safest lift in the world, but if the building itself is not strong enough to support its own weight, you are still stuck. The heavy masonry and thick stone walls of the old world could only be stacked so high before the bottom layers would begin to crumble under the immense pressure of everything above them. To truly reach the clouds and build the giants we see today, we needed a new kind of skeleton for our buildings. We needed a material that was significantly lighter, stronger, and cheaper than anything that had come before in human history. That change was just around the corner, waiting for its own moment of industrial transformation. In the next part of our story, we move forward to 1856 to see how the next breakthrough in steelmaking would change the stakes once again. This new era of cheap, mass-produced metal would take the safety of the elevator and give it the rigid frame it needed to reach impossible heights. If you are enjoying this journey through the hidden history of our world, make sure to stay tuned as we explore how the ingredients of the modern age finally came together.